Hey guys, Mr. Jones here, and we're going to be talking about graphing lines in this one, and that's our new unit here. Okay, so with graphing lines, we're going to be talking about this equation that's going to be big in this unit. The slope-intercept equation, y equals mx plus b, okay? Are going to be y equals m times x, and we're going to talk about a lot about what this m number and what it means, okay? So I'm going to kind of break that up between the m number and the b number. So you might remember M, I like to say M stands for move. You might also remember the official name for M is the slope. Okay, so you'll hear me say that a lot. M is the slope. So M being the slope and telling us where we move, right, that number is really going to determine if it's a really steep line, if it's really not steep, close to being horizontal, or if it's going kind of incline or a decline in direction and all that. So this first one says graph the linear equation, and just explaining this word linear, okay? Linear, the official meaning of that is that it's an equation that its highest exponent on a variable is 1. But the key with linear, right, it's really easy because you see the first four letters are line, L-I-N-E, line. So all linear equations, or ones with just a plain old x, like there's no x squared or x to the third or anything, we'll talk about those later, but slope, okay, slope is, again, the number that's multiplied by the x, so it's the number right with the x. So here that is 2. So my m value is 2. But you might also remember that I mentioned for slope, something that you want to remember is that slope, it's helpful to think of it as a fraction, and we call it rise over run. Now, what does that mean? I broke it down in the last unit too, but in a graph, there's two different directions. There's up and down, right? Up and down is kind of one separate direction, and then there's side to side as well. So rise deals with the up and down, and run deals with the side to side. That when we look at my m value, we want it to be a fraction, okay? Because without seeing it as a fraction, it's easy to forget that there's two different directions I'm worrying about, okay? The up and down and the side to side. So if it's a whole number like this one is, remember I said last unit too, you change that to a fraction, okay? 2 over 1. And then what does that mean? What does that mean? Well, if I have a line, okay, if I have a line, and I'm going to start this one right in the middle, okay? And again, that deals with the b value where it begins. But for now, I'm just going to start focusing on the slope. Okay, 2 over 1. That's my slope here. Okay, so the top number of my m value, the number multiplied by the x, is telling me how many spots I'm going to move up or down. Okay, and you think about that. That's the y-axis. Okay, and that's the x-axis. So here, my rise would be positive 2. Okay, positive 2 is my rise. And so on the y-axis, going up is the positive direction, right? And so if this is positive 2, I want to move up that many spaces, okay? This m value oftentimes is negative as well, and if it's a negative number, then you move down. But for this one, we move up 2 spaces. So it's when you're first learning this, it helps to draw, I call it your little steps, okay? So it's like a set of stairs. So that's my rise. And then my run, your run is just about always positive, okay? And that's helpful for consistency, right? So I have left and right, but just about every time it's going to be moving, you're thinking of it moving to the right, okay? This bottom number, which here is 1, is telling you how many spaces you're going to move right, okay? So I move right 1 space. And that's where my next point is, okay? That's where my next point is going to be. And then the characteristic of lines too is that they're very consistent, right? Lines never, like a straight line at least, never like curves off. And that's what all these are, straight lines. So we can move them. They're moving in the same direction each time. And so that kind of up to right 1 direction is how this line is going to be moving every single time. So I keep that going, that same pattern, up to right 1, new point, up to right 1, new point. So it's going to be like that the whole time. I really want to nail down here, what is my m value? What is my slope? And what does that tell me? And so hopefully you see here, that's telling me how many spots I'm moving to get to each point. Okay, let's look at another example here. Let me erase this. Okay, so I've got example 2 here. And example 2 says, it's similar, but it says y equals 1/3 x. But what's my m value? Well, my m value is just the number that's connected with the x, and that is here, that is 1/3. And notice it's already a fraction, which is awesome. So I don't have to worry about putting it over 1 like I would with a whole number. okay? So my rise and run are these two, right? So my rise is 1, okay? And remember, that's telling you how many spots you're going to move up or down. And because it's positive, we're going to move up that many. And then run, that's positive 3. So that's telling me how many spots I'm going to move to the right. And so again, for these, let's just start right in the middle. That's kind of the default place to start, at that origin point. And then let's move that many spaces. So I move up 1, because that rise number is 1. And then I move right 1, 2, 3. Up 1, right 3. So up 1, right 3. Okay? And so that's where that point would be. And then up 1, right 3 again. There would be my line y equals 1/3 x. And then again, to reverse that, I can kind of do the opposite direction, right? Instead of going up 1 and right 3, negate both of those. Instead of up 1, I could go down 1. And then instead of right 3, I would go left 3. And so my first point going the other way would be there, and so on. So that'll be that's example 2 there in purple. Let me draw my first line, y equals 2x. Let me sketch that on here real quick so we can compare them. Okay, so here's comparing the two, right? This is the first one we did, and here's example 2 that we just did. Compare these, okay? What would you say? The words that I would look for my students to use would be that the pink line is a lot steeper, right? Steep meaning close to vertical, right? You think of like a cliff being very steep, whereas this one is not as steep, right? Or more flat, right? You notice, let's compare the slopes in the equations and see why that happens, okay? So this slope is 1/3, okay? 1/3. So, and that's the purple line on my graph. So that's the one that's not very steep. Now, whereas this slope of the pink line is 2, okay, so you notice that is more steep, okay? And so you might be saying, okay, so the bigger the slope is, the more steep it is. And that would be just about true. Okay, let me do example 3 with you. And I'll just keep that on here. Let me get a different color marker. There we go, example 3. Graph the linear equation y equals negative 3x, okay? And so again, we're going to compare that to the lines that I already have up here. Okay, and what's different about that? Well, the m value for the pink one is 2. The m value for this one is 1/3. This one's negative 3. So this is my first negative slope. So let's compare how that is going to look compared to these two. Okay. And normally we don't draw all these lines on the same grid like this. Usually you just draw one, but I think it's helpful to compare them. Okay. So my m value here is negative 3. But again, I want it to be a fraction, right? So if it's not given to me as a fraction, I think negative 3 over 1. So my rise here is negative 3. And I'm not really rising, right? Because a negative in the y direction, right, is not going up like these ones, but it's going down. So this is actually telling me I'm going to move down 3. And my run, even though the slope is negative, right, I would still think this is positive 1, and I'm still going to move to the right. So again, I start in the middle, okay? That's where we're starting with these. And then I move down 3, 1, 2, 3, and right 1. So there's my first point. Okay, so you notice I'm moving in a much different direction. Down 3, right 1. Keep moving in the same way. But you notice, wow, that line is going in a much different direction. But kind of why I wanted to do this one here is going back to that steep part I talked about, okay, with it being steep. So my question to you is, would you say this green line, would you say that's steep or not steep, or closer to being flat? And I would say this is steep. I would say this is a steep line, okay? So maybe the rule that you said of okay, the smaller the number is, the less steep that it is. That's almost true, okay? But that what kind of proves that wrong would be this negative 3 slope, because that's smaller, right? Negative 3 is smaller than 1/3, but it's more steep. So a rule I would say for slopes is that, so the closer a slope is to 0, the flatter the line is. That's a good rule of thumb, okay? So the further the slope is from 0, this m number, the further that is from 0, the more steep it's going to be, the more almost vertical it's going to be. So 0, right, is there. So if I move 1, 2, 3, 4, 5, so the further I get from that, it's going to be closer and closer to being a straight vertical line. Okay, but the same is true with negative. Okay, the further I go from 0, negative 1, negative 2, negative 3, -4, right? The further I get from 0, the closer to the vertical it's going to be, okay? So just this first one here, I have 3 different equations, and it asks us to graph each of these. Y equals x plus 7, y equals x minus 1, y equals x minus 5. And just a quick 5-second review on m value, right? You notice if I was to ask what the m value was for each of these equations, again, you wouldn't say the m value here is 7. You wouldn't say the m value here is -1, and so on. Okay, the m value is the number multiplied by the x. Okay, so it would be a number. If there was a number right here, that would be the m value. Okay, and it's not showing one for any of these equations, right? It doesn't say 2x plus 7 or 3x plus 7. It just says x plus 7. Okay. And so when that happens, what does that mean? Well, that means that the m value, okay, for this one, the m value would be 1, or as a fraction, right, because we want m values to be fractions, 1 over 1. What I want to focus on here is these different b values, right? Because again, you know these are b values because they are after, they're being added or subtracted to the x. And what does the b value tell us, okay? Again, I have these handy posters hanging in my classroom. So I'll show them to you here. B value, again, I said B stands for begin. And so that's going to be helpful for us here because in the last video, I began drawing all my lines right at the middle, at the origin. And that's when the B value would be 0, okay? And so you notice none of the equations in the last video had B values shown. They were all 0, okay? But here, the B value is going to be where I begin, specifically on this y-axis. And that's helpful to see on the second poster, right? 0 comma b. Okay, so, and again, we laid this out in Unit 3 a little bit, but the b value, it's a point, and it's whatever the y value is, okay, or whatever the b value is, that's going to be the coordinates of my point, but it's going to be on my y-axis, okay, and that's my official name for the b value. We call it the y-intercept, and that's just a fancy way of saying where it touches the y-axis. So let's get into it. Y equals x plus 7, that's going to be my blue line here. And so I go where I begin, right? When I see this b value of 7 or +7, I go up to +7 on my y-axis. So that's a point where I start, okay? And then from there, it's all about the m value. And again, the m values here are going to be easy because they're all 1 over 1. So I go up 1, right 1, new point. Up 1, right 1, new point. Up 1, right 1, new point. Let's compare that to my red equation here. My red equation is y equals x minus 1, okay? So that minus is important too because that's going to say, that's the same as saying -1 as a b value, okay? So I begin, or my b value is going to be -1. So on my y-axis for this one, I go to -1 and make a point there. But then again, my slope is also 1 over 1 for this one, right? Because you see the m number would be the same, or it's not really showing it. I could write 1x minus 1, but they don't show that usually. So 1 over 1 is my rise over run here. So I go up 1, right 1, up 1, right 1, up 1, right 1, and so on. So there we go, okay? So you can see, what does my b value do? If my b values are different, okay, the lines themselves don't look all that different, okay? In fact, if you might be able to recognize that these are what we would call parallel lines. Parallel lines, meaning they're going the same direction the whole time. They're never going to intersect. And that's true about lines that have the same slope, okay? But anyway, the b value, you notice, that changes where I begin drawing my line, or where it touches the y-axis. So when that's different, it's almost like pushing the line down or up a little bit, okay, when I change that b value, okay? The shape, or where the line is moving, doesn't change much, or change at all, but just where it starts changes, okay? Let me show you that with one more. Okay, y equals x minus 5, so you can imagine -5. -5 is my b value, and so I begin at -5 on the y-axis down here, and there's my point. And again, slope is same thing, 1 over 1. So I go up 1, right 1, up 1, right 1. And so again, you can see that it's the same, right? It's the same shape, same direction, and it's also parallel to these two, okay? But it just begins at a different spot. It's kind of like I pushed it down a little bit more, right? And so that's what the b value does. The b value only really changes kind of where it starts on the y-axis, okay?